Okay, another type of problem you might see is multiple recursive calls to a function. If, oh, okay, grammar mistake here. If I believe the input of a function is another function, solve the input first. All right, we're gonna ignore the A. Okay, so this is just kind of the same thing as the last one, except this time we just have more function calls. Sometimes this can get a little annoying because you have to kind of keep track of which F you are at. There are 3 Fs here. It's a little bit easier to keep track of. Gets a little bit more annoying when it goes above 3. But first of all, to know this, we kind of need to know what F of 3 is, right? Since this seems to be the most simplified unit in this expression. And this is also what we have a function defined for. We don't have a function defined for f of 3 or f of 3, but we do have one for f of 3. So let's solve for f of 3. And here we're defining the function f of x as if x is greater than or equal to 4. Well, x isn't, so let's take a look at the next statement. If 0 is less than x is less than 4, well, this seems to fit. So our function is going to equal to 3x. In this case, if I quickly take a look at the other possibilities, this isn't really a recursive function since it's not calling itself. F of x isn't calling itself, but it is multiple recursive calls with the same function. So this kind of mimics a recursive function. All right, so f of 3 is 3 times x, which is 9. And then you can kind of replace that up here with a 9. And we still can't solve for this yet, so let's solve for f of 9 next. F of 9 is, well, 9 is greater than or equal to 4, so we're going to use x plus 1 here, which is 10. And then we're going to place this with 10. And finally, we can solve for f of 10, so we're just going to put this in. And we see that 10 is greater than or equal to 4, so our answer is going to be 11. All right. Oh, more practice. So this time we have a kind of function operator defined here. It's going to say brackets x is equal to the greatest integer less than or equal to x. Essentially what it's saying is this is the floor of x. So if you had like 5.5, and it's basically saying if you have brackets 5.5, I should say, this will be equal to 5. Just chop off the decimal point. And it doesn't matter if this was like 5.999, it's still 5. Once it goes to, say, 6.0001, though, that becomes 6. So that's the floor function. And, oh, this time we have 4 F's here. So we're going to have to use our technique again, just kind of write it out. 50, 1, 2, 3, 4, right? 1, 2, 3, 4. Okay, so we're going to solve for f of 150 first. Well, as you can see here, this is a little bit different from before. We have 2 if statements where you might call the function on itself again. And you do have to keep in mind of the floor function. So this is a little bit more complicated, but the idea is still the same. So first we check 150. 150 is greater than 20. So fulfills this first statement here. And we're going to have to do f of this brackets 150 divided by 5 minus 2 and plus 10. This is a little bit more simple since 150 is directly divisible by 5. We can just simply replace this with a 30 and of course replace this with a 28. And then we're going to solve for f of 28 here. 28 is greater than 20, so we're going to use this same statement again. Here's where we actually have to keep that rule in mind. So 28 divided by 5, we know that's like 5 point something. But since we're just taking the floor, we don't have to know what that something is. So we're just going to replace that with 5 and then replace that with 3. So now we can solve for f of 3. 3 is less than 10. And so we can just directly use this last statement here. this floor of 3 divided by 2 plus 3. This will be 1, and this will be 4. And then you can replace this with 4, solve for it, you get 14. And then, oh, I see, hang on, we're not there yet. Getting a little bit ahead of myself here. We replace that with 14, solve, get 24, replace this with 24, and now we have to solve for the next one. Okay, so f of 24, back to this cycle, x is greater than 20, so we're going to take 24 divided by 5, minus 2, plus 10, 24 divided by 5, the floor of that is 4, so 4 minus 2 is 2, so we solve for f of 2 here. F of 2 is the floor of 2 divided by 2 plus 2. This evenly divides into 1, solve to get 3. Replace this with 3, solve to get 13. See where f of 24 appears. Okay, all the way up here, so we replace that with 13. And then we go back to the cycle of solving for f of 13. F of 13, well, 13 is between 10 and 20, so we're going to use the second statement. F of the floor of 13 divided by 3 plus 2 minus 5. The floor of this becomes 4. This becomes 6. F of 6 becomes 6 divided by 2 plus 6. And then this is 3, so we solve and get 9. This is also 9, solving at 4. And then, okay, replace the f of 13 all the way up here. And then finally, we solve for f of 4. We haven't solved for this earlier. Interestingly enough, we solved for f of 2 and f of 3. But f of 4 will be 4 divided by 2 plus 4. So this is 2. And our answer is 6.